Alright, so in this question we want to take the function x times the square root of sine of x on the interval from 0 to pi, and we want to spin it around the x-axis so it forms a solid, and we want to find the volume of that solid. So this graph is going to look something like this, where this is pi, and then 0, of course, it starts at the origin. So this cross section is going to look like this, and then when we spin it around the x-axis, we're going to get these disc shapes that get formed as we go 360 degrees around. So what we want is an expression for the area of each of these discs. So the area is just going to be pi times the radius squared, where the radius is just f of x. So our area is going to be pi times x times the square root of sine of x squared, which is the same as pi times x squared sine of x. So that's our expression for the area. So now we want to integrate this area over our interval of interest, which is from 0 to pi. So let's go ahead and do that. First things first, we can pull out that pi because it's a constant, and then we can just rewrite the rest of this. And so now this integral we actually need to do by integration by parts. So let's pick u is equal to x squared, which would make du equal to 2x dx. dv is going to be sine of x, and then v is going to be negative cosine of x. Okay, so if we go ahead and solve this, we want to keep in mind that the expression for integration by parts is u times v minus du times v. So if we write that out, it's going to look like this. So u times v minus the integral of du times v. And the way I like to remember this is just thinking of minus dov, and then just keep in mind you're taking this integral right here. So if we plug in for u and du and v, we are going to get negative x squared times cosine x minus the integral from 0 to pi of 2x negative cosine x. And then just this first term here also needs to be evaluated from 0 to pi. Okay, so let's go ahead and solve this first expression. This is going to be negative pi squared cosine of pi minus 0, because you plug in 0 to x squared and that's just going to be 0, so that's going to cancel. And then the second term becomes plus 2x cosine x. We'll just simplify a little bit. And this we also actually need to do parts for as well. So let's just do parts again. Now our u is going to be x. Our du will just be dx. Our dv will be cosine x this time. And v, I'll make this a sharper v, our v will be sine of x. Okay, so now let's break down this integral. So this is set. We'll hold on to this, keep it for later. And now we'll work out this other expression. So we have 2 times, remember this is u times v, so this is x times sine of x. We want to evaluate that from 0 to pi, minus the integral of v times du. So this will be the integral from 0 to pi of sine of x dx. So this first term right here is our uv. This second term is our v times du. I'll go ahead and close that bracket. So this is going to simplify to 2 pi times sine of pi minus 0, and then sine of pi is also 0. So that whole first term is just going to cancel out completely. And then this integral, we have minus the antiderivative of sine of x is negative cosine. So this is going to become a positive. So cosine of x from 0 to pi. All of this written out is going to be 2 times cosine of pi minus cosine of 0, which is 2 times -1 minus 1, which is -4. Okay, so that's our second term, and then just remember we switch back to gray here, we had this negative pi squared cosine pi, which we're just bringing down from up there. Cosine of pi is -1, so we'll call this pi squared, and then we bring over this -4, and we end up with, there we go, pi squared minus 4. Oh, and then just remember we pulled out this pi at the very beginning right here, so we need to go ahead and multiply that back in. So our final answer is going to be v is equal to pi times pi squared minus 4.